One of the most important data structures in Ruby is the hash, and we will look at these next. Hashes are sometimes also called maps or key value data structures or associative data structures, and they provide a lot of flexibility to capture structured data beyond what arrays allow us to do. Now, before we dive deeper into hashes, let's recall Ruby's arrays. Remember that an array is basically a map from the set of indices 0, 1, and so on and so forth to the set that contains the values, the elements of the array. And so in this example here, what we have is the array A, where we assign the elements to be 1, 2, and 3 of their respective types. And the indices of this array range from 0 to 2. And the elements or values of the array at the respective index are the string 1, the integer 2, and the float 3.0. A hash is very similar to an array, with the exception that now, instead of just allowing integers as the indices into the data structure, we can use pretty much every data structure as an index type. So a hash H is a map from a set K of keys, what we called indices in the array, to a set V of values. So H is simply a mapping from keys to values. And the keys and the values can contain arbitrary Ruby values. So let's look at an example. Here the hash H is created using the standard notation in Ruby for it, where we use opening curly braces to create the hash. And then we give an index or a key, in this case the string name, and using the equals and greater sign, which is often also called a hash rocket in Ruby, we map the name to the element, another string, Bilbo Baggins. Separated by a comma, we give a second key value pair, and this is the age, or the string containing age. Again, the mapping with a hash rocket to 111. So we have now created a hash in Ruby, and it has two key value pairs in it. The first key value pairs maps name to Bilbo Baggins, and the second key value pair maps age to 111. And from this simple example, you should already be seeing that hashes can be very usefully applied when you need data structures, ad hoc data structures, where you want to relate keys with values. We can look up elements of our hash by giving an index or a key. So similar to the array notation we saw, we list the name of the hash, and then we give the index. And remember, this is one of the indices we introduced when we defined the hash. So name is an index into the hash, and it should yield Bilbo Baggins for us. So this is the lookup in the hash. If we look up at an index where we haven't actually stored anything in the hash, again, similar to what we saw in the arrays, we get a nil, not an exception. And we can also set the value. So for instance, for Bilbo Baggins, let's say we want to change the age key value mapping so that it maps from age to 75. We simply perform the assignment like so. And if we want to add an additional key value pair, we can simply add the pair by creating the assignment and that creates a mapping in the hash for this key value pair. Let's try it out in the REPL. We create a hash h using curly braces and then a number of key value mappings. So we go from name using the hash rocket to Bilbo Baggins, and separated by a comma we can give another key value pair. The key is h and the value is 111. And this gives us back the hash as it is created by Ruby. We can look up in the hash by giving a particular key, the key being name here, and we would expect to get back Bilbo Baggins because that's the key value pair we have added to the hash h. And we do. And if we look up a hash that, or under a key that we haven't even specified yet, we will get back nil. We can change the value under a key by performing an assignment. And if we now look at h again, we see that h now maps to 75. We can add a key value pair that hasn't been in the original hash by using assignment. So h has now 3 key value pairs. First the name mapping to Bilbo Baggins, the age mapping to 75, and the height mapping to 2.5. Let's quickly go over some methods available for hashes together. Size determines the number of key value pairs in a hash. So basically all of the pairs determine the size of the array. We can ask if the hash is empty and we will get back true or false. If we want to see only the keys of the hash, we can get back an array of all the keys by calling the keys method. And similarly, we can get back an array of all the values by calling the values method. If we want to have a sorted array containing a sequence of key value pairs in sort order, we call the sort method. If we want to have the hash as an array of key value pairs, so each entry in the array is a pair of key and value, we use 2a. If we want to remove a key and the associated value from the hash, we call the delete method with the key as an argument. And if we want to remove all key value pairs from a hash, we simply call the clear method. At the IRB, we see the size of h is 3 because we have 3 key value pairs in there. Is h empty? No, it's not. Let's see if an empty hash is empty. And it is. Let's see what h's keys are. And we get back an array consisting of name, age, and height. H's values are Bilbo Baggins 75 and 2.5. h.sort gives us a sorted array of key value pairs, and you can see here that the sorting is by the first element. So age, height, and name, and accordingly for the values. h2a will give us an array of key value pairs where the individual key value pairs are also in an array. We can delete from the hash, let's say, the age key value pair, and we get back the value for that key. And if we look at H again, we see that the H key value pair has been removed. And if we want to have all of the key value pairs removed from H, we call H clear, and H is then changed to the empty hash. Ruby also provides methods for iterating over hashes so that we can get access to the key value pairs or to the keys or values in sequence. So let's say we start with the hash as defined here, which maps name to Bilbo Baggins, age to 75, and height to 2. The each method iterates over each key value pair as an array. So it returns each entry, key value entry in the hash as an array consisting of a pair key comma value. And so if we use h.each, iterating again with a code block here where we introduce the kv variable and print it out on a fresh line, we would see pairs of keys and values in the variable kv. We can separate out between the key and the value, and in the code block, so we can introduce two parameters, k, v, and this will separately assign the key to k and v to v the value of a particular entry in the hash. And so when we print out k and v, we would expect to see the key in k and the value in v. Similarly, we can iterate over each of the keys, and in this case, of course, we then have only in k the keys, the respective keys in sequence, and we can print those out. Analogously, we can look at each of the values and iterate over each of the values and print out each of them in sequence. So let's create an entry again here in H via the name, which we'll map to Bilbo Baggins. And we want this as a string. And we introduce the age mapping to 75 and height shall map to 2. So we have our hash. Now we can iterate over each of the elements in the hash, and we'll first collect them in a single variable, which I call kv, and we print kv. And so what we see here is that via pods we get arrays of two elements. This is the first array, but again, pods prints the elements in a new line. So name and Bilbo Baggins is the array for the first key value pair. Age and 75 is the second key value pair, and height and 2 is the third key value pair. Now let's iterate over each of the entries, but now we want them separately under key and value. And so this time what we'll do is we'll call pods, and we interpolate into a string where we give the key first and secondly the value. So now we have the name followed by Bilbo Baggins, age followed by 75, and height followed by 2. Let's look at each key. Again in a code block. And this gives us each of the keys, and age.each value gives us each of the values.